Hello everyone, I'm Young First. Welcome to my channel. It's a self-mock technical interview using English as a non-English native speaker. Today let's do another problem instead of the daily problem from LeetCode. I joined a crew coding club. The chairman will publish his problem list in this doc. It's public. I think everyone can see it. I think the order in this list is much better than the daily problem, because it's the relationship is more strong between problems. For example, you can see this week the topic of the problem is very similar. So let's start our video. Yeah, it's 402. I have opened it already. So let's read the problem. I think I did it before too. Yeah, it's I did it about half and a year. Yeah, in fact, most the typical problems in this code is the problems I solved. Especially for the small number ones. So let's read the problem together. Given string number presenting a non-native integer, so it's non-native when it's highlighted, and an integer k return the small after removing k. Okay. Yeah, k is s. So if you didn't solve the similar problems, it's very difficult at the begin, I think. Although it's a medium problem. Let's find some operation from the example. If we need remove 3, the weight of different digit is different because, for example, the higher digits is more powerful. Its weight is much more than the later digit. So we want the former digits is small as much as we can. So to achieve this goal, I think we need a algorithm named the increasing stack or queue. This stack is a stack with a property that the items in it is increasing. We can iterate from the backend to the for front end, and add it in the stack until reach our limit. For example, the length is 7 and the k is 3. So there are 3 digits left. So four digits left. So we push into the stack, push into stack, push into stack, push into stack, and here we need to the capacity is full, so we need to add it. If we want to add it, we must pop the element. So we can't. We can also choose not to push it in this position because 3 is larger than 2, so we not push it. And for this one, it's larger than 2, we not push it, just discard it. And for 1, it's less than 2, so we push it into the into the stack. So we get our final answer. Let's check this one too. We push it. And if we push is larger than 0, so we discard it. Yeah, that's right. So I think this algorithm is right. Can you propose some more opposite example? I don't think so. So let's write it directly because it's a familiar data structure. So I want to write the pseudo code and write it directly in the real C++ code. So let's define a stack char as and for char we need to iterate the num from the back end to the first end. So auto nums are begin and char is char c. So we get the character from the string and from the back end to the front end. with the R begin and R end is very common in the C++. I believe there are similar way to achieve this in other languages. So if S is empty, as as the size of stack is as capacity. The capacity is the length plus 1. If we can add it into the stack, we add it into stack directly. Else let me else if the if the top character in the stack is smaller than C, we discard C. Else less than equal, I think is it. We add C and discard the top. And I think there need a while loop and I stop. If it's less than yes, I think that's it. But it's a risk that that the first one is if the character in stack is R large than C, it will pop to end, and we can't get a final answer with the given length. So there is a risk here. For example, and the capacity is for example 3. We here we will in here we will pop and get 132. So it's so this is wrong because we only get length of 3. and we need to stop that. So we need to find this here size. So on a yeah, on it's round 2, I think. Mm, because sometimes we need to remove the large one in the stack. For example, uh, we got this change. For example, um, for example, in this sample, we will get 1, 2, 4, 5, and then it come to 1. We will get to 1, 1, 4, 5. Instead of the answer, we need to get 1, 4, 3. Yeah. So so it's round 2. Maybe we need to fix it. If we iterate the character from the begin to the end, this may be help because for example 5, 4, 3, 2, 1. Get the first 3 and pop that. Pop that. Get this. Yes, I think that's it. If the stack let me think it more clearly. From 1, 4 to 1 to pop that. Pop that. stack, I think, is more clear because in this way we could we can add this and pop that, and this and pop that. Back it. Yeah. Something wrong here. Let me check that. Let's start from the beginning. For this one, I marked the from end to the begin. So there is zero numbers larger than 3, and there is 1, there is 1, and there is 1, and there is 1, there is 1, there is 0. So we need to remove those 3, 1, and I think the array is the number amount that which less or equal than current item. So there is this is 1, this is 4, and this is 3. I think this is 2. This is 1, and this is 0. This is 0. So we need to remove this 3 1, this 2 1, this 3 1. We just pick the largest one to, for example, this. I did it from the end. This is 2 less than this is 3, and this is 2, this is 1, this is the show, and remove the largest one. I think the problem occurred to find the number amount which less or equal than the current item, and sort it and find the largest one and remove them. Yeah. Let's begin. Begin with the new algorithm. Let's get the length of the string and get the amount larger than n, and how to do that, and for we need to sort it and add it to pair and sort it and remove the largest one. So how to calculate the amounts which are less than? I think we need to calculate from the begin to the end, and okay. The first step is difficult too. We can iterate it first. Is a nested for loop to achieve this, but the time complexity is too high. It's very bad.